So for pi over 6, the arithmetic sequence is as follows. So it goes pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So pi over 6 is here, and then 5 pi over 6 is the same angle like that, and it goes like that. And then 7 pi over 6 is here. So this technique can be used for the rest of the values for pi over 6 in the unit circle, and it can also be used for the pi over 4 sequence. The values within the unit circle for this arithmetic sequence are pi over 4, so they're going to be right over here. So pi over 4. And then 3 pi over 4, so again it's the same angle. It's going to be the same angle here as it is right there. And so then after 3 pi over 4, it's 5 pi over 4, so it'll be over here. Again, same angle, these two correspond. And then lastly, it'll be over here for the last value. So using an angle from the unit circle to determine all trig ratios is quite simple. So for example, in quadrant 4, this example right over here, we can make the angle into a triangle to find x, y, and r, and then sub in values for the ratios. So you see that for quadrant 3, as it says in the casserole, the secant is positive, which is right here, and then sine, tan, cosecant, and cotangent is all negative, which is displayed here, so that's how you know this is correct because it uses the special triangle. So for the second Pythagorean theorem, you have x squared plus y squared equals 1, so x squared in this case is this squared, and then this squared, which is 3 over 4, and then the same thing here, so 1 over 4. So it's 3 over 4 plus 1 over 4 equals 4 over 4, which is obviously 1, so you know that is correct and your solution is right. And then cos squared plus sine squared equals 1. So if you do that, and then you multiply it all by r squared, it's similar to the a squared plus b squared equals c squared, which we know is proven correct, so that's fine. And then lastly, to find cos, and now to find cos of 0, sine of 0, tan of 0, etc., we see this. So this is 1 because 0 is on the point 1, 0, and cos is equal to x over r. Obviously for all of these, the reciprocal will have the same value. So because sine utilizes y over r and 0 is the y coordinate for 1 over 0, these two will have 0 as their answer. And lastly is my fifth point I just want to clarify, which is the ratio and what is the angle of all the numbers on the unit circle. So what we have here is 0, we start there, and then we go around. So pi over 6 is 30, pi over 4 is 45 degrees, and pi over 3 is 60 degrees, and then pi over 2 is 90 degrees. So from this, you can add them to get the next value. So this one's 120, 135, and 150 degrees, then 180, 210, 225, and so on for the rest of the circle until you reach 2 pi, which is 360 degrees. So obviously you have to keep in mind that you start at 0 degrees here and then go all the way around to then 360, as that is the degree in circles. And then for the ratios, to reiterate, so the sine of theta is y over r, which is the opposite over the hypotenuse. The cos of theta is x over r, which is the adjacent over the hypotenuse. And the tan of theta is y over x, which is equal to the opposite over the adjacent. And with the unit circle, you're able to solve most trigonomic ratios.